When you talk to an AI, it feels like it knows you. It follows the thread of your conversation and recalls specific details. But beneath the interface, the system has zero memory. Large language models are stateless systems. They possess no built-in mechanism to record the past or maintain a lasting history of who you are. Without an external intervention, every single prompt you send is treated as a total reset, the very first time the machine has ever interacted with you. The only short-term recall these models have is a technical limit known as a context window. Think of the context window like this container. It has a fixed capacity. Once it's full, the system hits a wall. To make room for a new message, the oldest information is mechanically forced out the bottom and deleted forever. Because an AI must forget its past just to process the present, personalization requires a system that functions outside of the model's own architecture. To solve this, engineers don't try to expand the AI's internal brain. Instead, they build external memory storage systems. By moving the data to an external database, the AI is no longer constrained by its context window. It only looks at the information it needs exactly when it needs it. This relies on a three-step pipeline: store, retrieve, and inject. This setup turns the AI into a librarian. It doesn't need to know everything at once. It just needs to be fast at pulling the right book from an infinite archive. Imagine you tell an assistant, "I like learning about AI," and that initiates step 1, store. The system doesn't save your words as text. It converts them into mathematical vectors called embeddings. These numbers map your interests into a 3D coordinate space, grouping similar concepts together. Weeks later, you ask for a book recommendation. Step 2, retrieve, begins. The system runs a search through its vector database, finding the coordinates that set closest to your past interests. Finally, step 3, inject. The system grabs those matches and invisibly pastes your old preferences into the new prompt before the AI even sees it. This hidden, behind-the-scenes injection is what creates the illusion that the machine has remembered you. Developers use this same pipeline to create different types of memory depending on the task. Conversational memory handles the immediate back and forth of your current dialogue. Semantic memory acts as a long-term encyclopedia for facts and general knowledge. And episodic memory tracks a historical log of specific events or timestamps from your past interactions. Layering these architectures together gives an AI agent a multidimensional understanding of its environment. When you look at the mechanics, the reality is clear. AI memory is an engineered simulation. Human recall is organic. The machine relies on mathematical storage, vector search, and hidden prompt injection. The personalization you experience is a byproduct of the external retrieval systems built around the language model. Moving past the limits of the context window turns a stateless calculator into a continuous partner. In our next video, we will take these memory pipelines and use them to build a functional AI agent from scratch. AI doesn't possess human memory, but mastering its simulation is a first step toward building autonomous systems.